Okay, so we have discussed in the previous lecture about how should we determine or whether we should have equal or unequal size class intervals, and we have also discussed how many class should we have, and then again we discussed what should be the size of its class, and how should we determine the class limits. So we have discussed the 4 questions that we should answer while preparing for a frequency distribution. And let me just give you an example of a continuous variable. We have discussed that variable are of 2 types, that is discrete and continuous. So this is just an example of a continuous variable. So let us say 30 kg of rice, let us say. So when it comes to we are measuring the frequency, or we are measuring the weight of a commodity, let us say. So in case of a continuous variable, your classes or your intervals or class intervals will look like this: 30 kg till 39.99 kg, and then 40 kg till 49.999 kg, and then 50 kg till 59.999 kg, etc. So what does it mean here? So 30 kg till 39.999 kg would mean 30 kg and above. So whatever values is above 30 kg and under 40 kg will be included here. So any value which comes above 30 and which comes under below will be included in this class interval or in this class. So that will be the frequency. Again here 40 kg above and below 50 kg. And what does it mean here? 50 kg above and below 60 kg. So this is an simple example of a continuous variable. And so we have talked about class interval and what should be the class interval and all those things. So we are just giving you an example how to adjust the class interval. So when question is asked adjustment in class interval, you should be able to calculate how to you should be able to adjust the interval following the steps. So this is table number 4 and table number 3.4, and this one is this is 3.5, table 3.5. Okay, here it is without adjustment in class interval, and here it is the adjusted one, the adjusted already for class interval. So what are we actually doing here, or what is the difference between this and this table 3.4 and table 3.5? What is their difference? So taking this table, we have adjusted the class interval by following some methods. So in order to adjust the class interval, what should we first do? So the first step is this one. So what are we actually doing here? We are subtracting, or we are finding the difference between the lower limit of the class and the upper limit of the class. So the first step is find out the difference between the lower limit and the upper limit of the classes. So find out the difference. That is the first step. So we have found out that the difference is 1 when we do minus. So what is our second step? So the second step is we divide the difference. That is, the difference here we got is 1. We divide the differences by 2. So we are dividing 1 by 2. So the difference that we got is 1. So we have to divide it by 2. And the answer we got is 0.5. That is the second step. So what is the third step? Here it is a little bit tricky and you should not get confused here. So third step is we have to subtract the value obtained. So we have obtained 0.5. So we have to subtract 0.5 from where? From the lower limits of all classes. Subtraction by the value that we have obtained to all the lower limit of the classes. So don't forget, it is the lower limit of the classes that we have to subtract with the value that we have obtained. The last step is, we have to add the value that we have obtained, that is 0.5. We have to add this value to the upper limit of the classes. So we have to add 0.5 to the upper limit, and we have to subtract 0.5 to the lower limit classes. So that is how we are adjusting the class interval. So after the adjustment of this table 3.4, what we have is the adjusted table for the class interval, and it will look like this. So this is the number of employees or the frequency. So we have adjusted the class interval following the 4 methods. That is, find out the difference between the lower limit and the upper limit, divided by 2, and then the next is you subtract the value that is obtained from all the lower class limit and add the same value to the upper class limit. That is how we adjust the class interval. So while constructing frequency distribution, the last question that we have to answer is, how should we get the frequency of its classes? So how should we get the frequency of its classes? So we are taking the example of table 3.1, which we have looked at in the previous lecture, table 3.1 and example 4. Refer to your the materials that I have sent you, table 3.1 and example 4. So frequency of the observation would mean how many times that observation occurs in the raw data. So observations, table 3.1, this is table 3. Observations would mean all these things. These are all observations. So frequency would mean, how often or how many times that those observations occurs in the raw data. So any observation, or how many observations comes under 0 to 10. This is the class. So how many times that values which are ranging from 10 to 20, how many times it occurs in the raw data? So 8 times it occurs. When frequency it is 8, we are indicating that 8 variables are there, which are inside 10 to 20. And 6, when we get frequency as 6, we are saying that there are 6 variables that is included under 20 to 30. So that is how we got the number of frequencies. Simple word, when we say frequency, would mean how often that variable occurs within this class interval. So how many numbers are there in the raw data, which is ranging from 10 to 20, and how many numbers or how many variables or how many observations are there within 20 to 30. If it is 6 variables or 6 observations, the frequency will be 6. So here we are going to talk about finding the class frequency by telemarking. So you must have seen or you must have used some this telemarking in in your day-to-day or practical life, and it is very helpful. So in this method, a tally is put against a class for each student, or any example that you have for a vote counting maybe, whose marks are included in that classes. So tallies are then counted as groups of 5. So you will understand when I demonstrate you here. So thus frequency in a class is equal to the number of tallies against that class. So here we are taking the example here. So class 0 to 10, we have frequency as 1. So how do we make into a tally? So 1 frequency equals to 1 tally. So in the next class 10 to 20, there are 8 frequency, which means 1, 2, 3, 4, 5, 5, 6, 7, 8. So that is the tally mark for frequency number which is having 8. So 1, 2, 3, 4, 5, 6, 7, 8. So that is how we make a tally mark. And in the class of 20 to 30, we have frequency as 6. So 1, 2, 3, 4, 5, 6. So that is how we make a tally mark. Next is 7. 1, 2, 3, 4, 5, 6, 7. So the next is 40 to 50. We have frequency 20. So how do we do? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1. So 5, 10, 15, 20, 21. So that is how we make a tally mark against the classes. Or so by doing this, we can conclude that, tallies are then counted as groups of 5. So one tally is a group of 5. So thus frequency in a class is equal to the number of tallies against that classes. So there are 21 tallies here, so the frequency is also 21. So that is how we find the frequency by tally marking. So what we are going to see now is the loss of information. So when we are, summarizing or making the raw data into frequencies, class mark, what happens behind this? We are losing information. So while summarizing data and making it concise and making it comprehensible, we are not able to get the detailed information about the raw data. So we are losing data. Loss of data happens and loss of information that happens because all the observations are not taken into consideration. And all values in the class are assumed to be equal to the middle class mark. So what we are taking into consideration is just the class mark and not the values of observation that is presented or that is there in the class. And further, statistical calculations are based only on the values of class mark, and not on the values of the observation in that class. So any statistical analysis or calculation is done only on values of the class mark, and it does not take into consideration the values of the observation in that classes. So let us take an example of class mark here. So we have the class mark and we have discussed how we got the class mark. We add up both the upper limit and the lower limit and divided by 2. So we got 5 here. And then here we got 20 plus 10 is 30 divided by 2 is 15. So that is the class mark and how we obtain class mark. So it is mainly or any statistical calculations or anything that we do, that we analyze or that we do statistically is based only on this class mark and not the many observations that is presented in the raw data. It is only this class mark that we are taking into consideration when it comes to statistical calculation or when it comes to analyzing anything based on data. So while doing so, we are losing a lot of information. So we have talked about only about the frequency distribution with equal classes. So here I'm giving you the example of a frequency distribution with unequal classes. So we are using the same raw data that is table 3.1 here. So looking at this, we will see that the class intervals are of different. So here the class interval is 10. Here it is only 5, only 5, 5, 5, and here it is 10 again. So when we are having unequal classes, the number of classes also increased to 13. Earlier it was only 10 here, 10 classes are here. But when we are breaking up or using this unequal class method, the number of class also increased to 13. And you will see the difference between the frequencies also. Here you will see that all the observations are accommodated mostly in this area. And when we break up, or when we are doing in unequal class method, so the concentration of the variables or observation is also spread out, thereby reducing the loss of information. So when we are breaking up these frequencies into larger frequencies, we are actually reducing the loss of data, which means your class mark will also change. And then while increasing the class interval, or you mean breaking up the class into unequal classes, we are actually increasing the class number of classes, thereby affecting the number of frequencies. Or earlier it was crowded or concentrated only in few classes, but after the use of unequal classes, it has already spread out to different classes. So what are we actually doing is we are trying to reduce the loss of information while we are getting the frequency distribution. So this unequal classes of frequency distribution reduces the loss of information. When you also plot these datas or points in the graphical manner, you will see the difference between the you'll see the difference of the curve when you are doing with the equal class interval or unequal class interval. So the graphical representation will be indicating the difference in the curve. Also the curve will change its shape. Okay, so far we have discussed the classification of data for a continuous variable using the example of percentage of 100 students, percentage marks of 100 students in mathematics. So for a discrete variable, the classification of its data is known as frequency array. If it is for the discrete variable, the classification of data is known as frequency array. So this is an example of a frequency array. So the class is of whole number. It does not take it is taking only certain definite values. So the variable size, the size of the variable of the household is a discrete variable that only takes integral values as shown in this table. So it is taking only integral values. So it is a discrete, not a continuous. So that is frequency array for a discrete variable. So when we classify this discrete variable into data, it is called frequency array. So the last topic is bivariate frequency distribution. So what does it all about? So in definition, it is given that a bivariate frequency distribution can be defined as the frequency of or frequency distribution of two variables. So it is a frequency distribution of two variables and not just one. And again, we will discuss in detail when we come to study about correlation. So when we discuss correlation, we'll talk more about this bivariate frequency distribution. So by looking at this example, you will understand what is a bivariate frequency distribution. So here it is given bivariate frequency distribution of sales and advertisement expenditure in lakhs. So the two variable is sales expenditure and advertisement expenditure. I mean sales, number of sales and advertisement expenditure. Here in this variable, we are measuring the advertisement expenditure. And here we are, measuring the sales. How much of sales or how many firms are able to sell within this range, 115 lakhs and 125 lakhs. So there are two firms or companies that is able to sell 115 to 125 lakhs having expenditure of 62 to 44 lakhs. So there are two companies or firms which is spending advertisement expenditure of 62 lakhs and 42 lakhs and making the sales of 115 lakhs and 125 lakhs. So this frequency 2 is measuring for both sales and advertisement expenditure. So a frequency distribution of two variables is called bivariate frequency distribution. Again here it is given 1. So this one indicates that there are one firm which has the sales of 115 lakhs and 125 lakhs and spending 64 lakhs to 66 lakhs. And again, there are one, firm or company which is selling 125 to 135 lakhs, spending 62 to 64 expenditure on advertisement expenditure. So these frequencies are, measuring. So as I have mentioned, these frequencies are for both sales variable and advertisement expenditure. So it is measuring for both sales and advertisement expenditure for two variables. So a bivariate frequency distribution would mean it is a frequency distribution for two variables. In conclusion of this chapter, the data collected from primary and secondary sources both, they are considered as raw and they are unclassified. So once the data are collected, the next step is to classify them for further statistical analysis. And this chapter should enable you to know how data can be classified through frequency distribution in a comprehensive manner. So once you know these techniques of classification, it will be easy for you to construct a frequency distribution for both continuous and discrete variables.